All right, welcome back to the deep dive. You know how we're constantly looking at ways to push the boundaries of what AI agents can do?
Absolutely.
Well, today, we're dissecting a really fascinating piece of research that tackles a fundamental bottleneck.
Which is?
How do we get these autonomous web agents to truly learn and improve over time? Especially, when faced with the messy complexity of the real web.
Right. They often master specific tasks, maybe in training.
Exactly. But then they struggle to abstract those skills to apply them more broadly. It leads to, overfitting and pretty brittle performance, doesn't it?
It really does. It's like that classic overfitting problem. Performs brilliantly on what it's seen, but stumbles on anything new.
So this paper, SkillWeaver, Web Agents Can Self-Improve by Discovering and Honing Skills, by Zhang and colleagues. It offers a different approach.
A very compelling one, yeah. It focuses specifically on this concept of reusable skills to overcome that limitation.
And for you, our technically minded listener, probably wrestling with similar generalization challenges, the core idea here, it's moving beyond just recording action sequences.
Right. SkillWeaver lets agents autonomously discover, synthesize, and then crucially refine website interactions into structured, reusable code.
Almost like building their own library of web-specific APIs.
That's a perfect way to put it, and this could really boost their performance and adaptability.
Okay, so for the quick takeaway, the first minute summary, autonomous web agents often fail at self-improvement and generalizing skills.
Yep, that's the problem.
This paper introduces SkillWeaver, a three-stage framework: skill proposals, skill synthesis, and skill honing. It lets agents learn reusable website interaction APIs.
And the results? Pretty striking. We're touching a 31.8% relative success rate bump on WebArena.
Wow.
And nearly 40%, 39.8% on live websites. And get this, even weaker agents got way better, up to 54.3% gains on WebArena using these synthesized APIs.
Okay, that's impressive knowledge transfer. So, SkillWeaver, it's all about these reusable skills. What's the sort of fundamental shift here compared to, say, just recording trajectories?
The key innovation, I think, is explicitly synthesizing these skills as executable code, not just action logs, clicks, form fills, but actual structured APIs.
But when they say APIs, we're not talking REST APIs, right? Not connecting different web services.
No, that's a crucial distinction. These are Python functions built using Playwright, the browser automation library.
Ah, okay. So the agent is essentially coding its own tools for interacting with the browser.
Exactly. It's moving from brittle macros to more abstract, programmable interactions. Definitely something our listeners building automation might appreciate.
Makes sense. So let's break down this three-stage pipeline. Stage one is skill proposal. How does the agent even figure out what skills might be useful to learn?
Well, this is where the LLM comes in, GPT-4o, again, acting as what the paper calls an automatic curriculum.
An automatic curriculum, I like that.
Yeah, it gets fed info about the website, screenshots, name, URL, and really importantly, the accessibility tree.
Right, the programmatic structure, not just the visuals. I can see how that helps, especially for navigating tricky dynamic content or complex sites.
Precisely. That accessibility tree gives it a much deeper structural functional understanding. Super useful for things like the CMS environments in WebArena, which aren't always visually obvious.
Okay, so the LLM understands the site. Then what?
Then it proposes skills, but the focus is on skills that are novel, extending what the agent can already do and reusable, and generally short horizon tasks.
Short horizon, meaning?
Things that can ideally be wrapped up in a single API call, not huge, complex workflows initially.
Gotcha. Starting modular, what kinds of skills does it propose?
The paper groups them into three types. First, procedural tasks automating a sequence of actions. The example they give is identifying pills on drugs.com using imprint and color.
Okay, like filling a form and clicking search.
Exactly. We'll see the API for that later. Second, navigational tasks, like learning how to consistently get to the customer review section on different e-commerce sites.
Building generalized navigation patterns. Makes sense.
And third, information-seeking tasks, scraping specific data, maybe learning to grab the latest commit messages from a GitHub repo, for instance. That might involve parsing HTML, not just clicking.
So the LLM is like a smart user identifying useful shortcuts. But how does it prioritize? Surely it proposes lots of things.
Good question. It doesn't just brainstorm, it rates them based on usefulness and the estimated number of actions needed.
Usefulness and effort, okay.
Yeah, how often might this be needed versus how complex is it to do? It prioritizes skills with high utility and relatively low complexity. The top-rated one moves to the next stage.
Which is stage 2. skill synthesis. This sounds like where the real heavy lifting happens, turning ideas into actual code.
Definitely. The goal here is automatically generating robust, reusable APIs. And it has 3 parts. First, skill practice. Yeah, the baseline agent, they use one based on Codact with Playwright, actually tries to perform the proposed skill repeatedly, learning from failures.
It's like iterative development, the agent debugging its own approach.
Exactly. And for information-seeking tasks, it actually involves generating the data extraction code itself.
Wow. Okay. How does it know if it succeeded in practice?
That's the second component, the reward model. Again, leveraging an LLM.
The LLM judges the practice attempt.
Right. It looks at the task description, the action trajectory with screenshots and descriptions and environmental feedback like code results or website changes. It gives a thumbs up or down, basically.
So the LLM is the idea generator and the quality checker.
Pretty much. And if the reward model says success, then the third component kicks in. API synthesis.
The code generation part.
This is where that successful action sequence gets turned into a reusable Python function. It generates the code, the function signature, parameters, everything. And importantly, a detailed doc string.
What's in the doc string?
Purpose, usage instructions, even logs of successful past uses. Plus, they run static analysis to catch common coding errors.
That's thorough. You mentioned that pill identification API example earlier. What does that synthesized code actually look like?
Yeah, figure 2 in the paper shows it. It's an async Python function, identify pill. Takes the Playwright page object, the pill imprint.
The numbers on the pill.
Right. And optionally, color and shape. The doc string explains it's for drugs.com, lists parameters, gives usage examples like 935510 white oval.
And the code itself.
Uses Playwright commands to navigate, accept terms, fill the imprint field, select color shape from dropdowns if provided, and click search. It's a direct translation of the successful actions.
You can really see the abstraction from clicks to a function. Much more robust. Okay, stage 3. Skill honing. What's this for? Testing.
Exactly. Even with the synthesis checks, APIs might not be perfect. Honing is about testing and debugging them for reliability.
How do they test them?
For simple APIs with no extra parameters, they just run them like unit tests. For APIs with parameters, the LLM generates diverse test inputs.
So the LM helps create the test cases too?
Yep. Trying to cover different scenarios, find edge cases, basically making sure the tool works before it gets used seriously.
It's like the agent is building its own QA process for its own tools.
That's a good analogy. Figure 1 shows the whole loop nicely propose, synthesize, hone. It's this continuous cycle that drives the self-improvement.
Okay, framework understood. Let's get to the proof, the experimental results. Where did they test SkillWeaver?
2 main arenas. First, WebArena. That's the standard benchmark, right? Simulated web environments across 5 domains: GitLab, Maps, Shopping, CMS, Reddit. Controlled automated evaluation.
And second?
Real-world live websites. They use tasks from the online Mind2Web benchmark, focusing on 4 sites compatible with playwrightdirects.com, a flight site, cooking, and a car site.
So simulated and real world, what did the numbers show? Did it actually work?
Yeah. Oh, yeah. The results were pretty strong. On WebArena, using GPT-4o as the main agent, adding SkillWeaver APIs boosted success rates by an average relative improvement of 39.8%.
Nearly 40% better on average. That's significant.
It is. And even more impressive, remember the weaker agent, GPT-4 Mini?
Yeah.
Giving it the same API synthesized by the stronger agent resulted in a 54.3% average relative improvement. Table 1 breaks it down by domain-consistent gains everywhere.
Wow, that transfer learning aspect is powerful. The skills themselves hold a lot of value. What about the live, messy, real-world sites?
Still very positive. An average relative improvement of 39.8% across those 4 online Mind2 websites. Table 2 has the details.
So comparable gains in the wild.
Mostly. There was an interesting case with the car website. The APIs helped navigate to the final stages in several tasks, but the agent still failed on the very last steps.
Why was that?
It seems those final steps needed a stronger understanding of the visual layout or context, something the API alone couldn't fully capture.
A good reminder that it's not magic, right? There's still hard problems in web interaction.
Definitely. But overall, a clear benefit.
Now, generalization is key. Can these skills adapt?
They looked at 2 kinds. First, across websites. Because skills are packaged into website-specific code files, the main agent doesn't need site-specific logic. It just loads the right API library.
So it adapts it by loading the right tools.
Exactly. And the consistent performance gains across diverse sites in WebArena and the real world suggest this works pretty well. It's learning something more abstract than just click here on this specific page.
That's crucial for dealing with website changes, something anyone doing web automation worries about.
Absolutely. The second type was generalization across agents. We already touched on this.
With the weaker agent getting a huge boost.
Right. Providing the APIs synthesized by GPT-4o to GPT-4o Mini led to massive improvements, sometimes over 100%. In some WebArena domains, the Mini agent with skills actually beat the baseline GPT-4o without skills.
That's wild. It really shows the power of encapsulating that procedural knowledge, like giving a junior dev a great library.
Precisely. It democratizes the capability in a way.
Now, WebArena has its own human-written APIs for some sites, doesn't it? How did SkillWeaver's auto-generated ones stack up?
Good point. They did compare. On sites with low or medium human API support, like Reddit or the shopping site, SkillWeaver's APIs performed comparably, sometimes even slightly better.
So it can autonomously create high-quality APIs in those cases?
It suggests so, yeah. Figure 3 shows this. However, on sites with extensive human API support, like GitLab or Maps, the human-crafted ones generally performed better.
Okay, so human expertise still wins for really complex, well-defined platforms. But SkillWeaver holds its own, especially where APIs are sparse.
That seems to be the takeaway. It's very effective, particularly in less structured environments.
Did they highlight any interesting emergent behaviors in the case studies?
Yeah, one really cool thing was the emergence of compositional APIs. After learning some basic skills, the agent started creating more complex APIs that called the simpler ones it had already learned.
Oh wow, building blocks.
Exactly. The appendix has an example for applying multiple search filters. The high-level apply filters API calls lower-level APIs for closing an overlay and then applying each filter individually. It shows abstraction.
That hints at a path towards tackling much more complex, multi-step tasks, doesn't it?
It really does. As the library grows, the potential for orchestration increases.
Were there clear limitations or common failure modes identified? No system is perfect.
Absolutely. They were upfront about it. A key issue is that even good LLMs aren't perfect at using the APIs once they're created.
Ah, the API calling part.
Right. Two main failure types. Sometimes the LLM picks the wrong API for the job.
Misidentification.
And other times it picks the right API but provides incorrect parameters, wrong format, wrong values.
Okay, so generating the tool is one thing, using it effectively is another.
Exactly. The appendix gives examples like trying a recipe search, using a cuisine API, or messing up keyword formats.
That seems like a natural next step for research improving the agent's strategic use of its own tools.
For sure. They also noted a limitation in how they verified skills. Since no error meant verified, some poorly made APIs that just suppressed errors could pass.
Ah, the silent failure problem. Tricky.
Yeah, highlights the ongoing challenge of robust evaluation in these complex agent systems.
Well, this has been incredibly insightful. Pulling it all together, what are the main takeaways for our listeners from SkillWeaver?
I think the biggest thing is that it offers a concrete, effective way for web agents to actually self-improve, moving beyond just recording actions to discovering, building, and refining reusable APIs. That's a major step.
It tackles that generalization problem head on.
It does. And the results show it works, both in simulation and the real world. The knowledge transfer to weaker agents is also huge, I think.
Making sophisticated web interaction potentially more accessible.
Right. And that emergence of compositional skills, even if early, points towards handling much more complex tasks down the line.
While also acknowledging the remaining challenges, like reliable API calling and verification.
Exactly. It's great progress, but also clearly lights the path for future work.
So for everyone listening, especially those building agents or complex automation, here's that final thought to chew on. How do we scale frameworks like SkillWeaver? How do we get them to handle really long, complex tasks requiring intricate skill orchestration?
And how do we make them truly robust to the constantly changing web, adapting on the fly?
What does this autonomous skill learning mean for AI that can navigate the digital world like we do? Lots to think about. If you want the nitty-gritty details, the paper and code are on GitHub. The link's in the description. https://github.com/u-NLP group SkillWeaver. Definitely worth checking out. Thanks for joining us for this deep dive.
Yeah, fascinating stuff. A really promising direction.